Today we're going to look at function tables, and the first thing we're going to do is look at a few vocabulary words. So first, if you're taking notes and you've ran off your note page, a blank is a relation. Remember, in our last lesson, a relation is a group of ordered pairs. So a blank is a group of ordered pairs or relation in which each member of the domain, remember the domain are the x values, is paired with exactly one member in the range, and remember that the range were the y values. This is called a function. A function is a group of ordered pairs where each x value is paired with one y value. A blank is the operation or operations performed on the domain value to get the range value, and this is called a function rule. Here at the top of the table, you will see the function rule for this function, y equals 3x plus 1. And a blank is a table that lists the x coordinates, which are called the input. It has the rule and any y coordinates, the output. And this whole entire thing is called a function table because it has all of it. It has the rule, it has all of the x values called the domain, and it has all of the y values. So a function and a function table. So let's look at this. We are going to read the scenario and we're going to make a function rule, an equation that we can use to fill out the rest of the table. In a game of What's My Rule, Kenna picked the card shown at the right. Make a function table for 4 different input values and write an algebraic expression for the rule. Then state the domain and the range of the function. So here's the card. It says, what's my rule? Double a number, then add 3. Now we have been working on translating algebraic expressions, and when we said that you have the word double, that means you're going to multiply a number times 2. So we know that's going to be 2 times a number, then add 3. So all we did so far was just translate that algebraic expression, 2x plus 3. Now since this is a function, we're going to write it as y equals 2x plus 3. So here's double a number plus 3. That's what our y, that's what our output is going to equal. Now I've put the rule over here in our function table. Now we have the domain. Remember that the domain is the same thing as saying the x values or the input. These are 3 different ways to say the same thing. X values, input, domain. They're all synonymous. They mean the same thing. So now we know what to plug in to our rule. Notice this is x. So we're going to plug it into x in our rule, and we're going to solve for y and see what the output or the range would be. Range and output and y are all synonymous as well. So let's see what this looks like when we plug it in. So if we plug in a 1 to x, that would be 2 times 1 plus 3. We have to follow our order of operations, so we would go 2 times 1 first, then add 3, and that would be 2 plus 3 equals 5. We just created an ordered pair. The ordered pair is 1, 5 for the x and the y values. Now we're going to plug in 2 to the same equation. That would be 2 times 2 plus 3. Again, we do the multiplication first. 2 times 2 is 4, plus 3 is 7. Plug in 3. 2 times 3 is 6. Then we add the 3, and that would create 9. Plug in the 4. 2 times 4 is 8. Plus 3 is 11. So we used the rule that we had, and we filled out the function table. I'm going to erase all this. And we have created 4 ordered pairs. We have created the order pair 1, 5, 2, 7, 3, 9, and 4, 11. If we had a graph, we could graph these. Now, what is the domain? Remember domain, the definition for that are the x values. So you find the domain by just looking at the x values. So the domain is 1, 2, 3, and 4. The range is the same thing as the y values or the output. So what were the ranges? 5, 7, 9, and 11. Okay, here's our next example. And the navigation message from a satellite to a GPS is an airplane. In an airplane is sent once every 12 minutes. Write an equation to find the number of messages sent in any number of minutes. This time we're going to change the letters. We're going to let t represent the time. So instead of using the variable x, we're going to use the variable t. And n represents the number of messages. So instead of using the variable y, we're going to use the variable n. That just gives meaning to it, number and time. So if a message is sent every 12 minutes, all I would have to do is take the number of messages, or the number of messages equals the time, the number of minutes, divided by 12. So that is our function rule. Now, sometimes they even tell you what they want to go into the input. This says make a function table to find the number of messages in 120, 180, 240, and 300 minutes. Since we're talking about minutes, which is time, these are our x values, so we're going to plug them into our table here. 120. Now we're going to use our rule. We're going to plug it into t right here. So to find the number of messages, you take 120 and divide it by 12. So the number of messages would be 10 in 120 minutes. Now we do 180. If we plug that into the equation, we have 180 divided by 12, which is 15 messages. If we plug in 240, 240 divided by 12 is 20 messages. And then if we plug in 300, 300 divided by 12 is 25. Now again, we've created order pairs. We have 120, 10, 180, 15, 240, 20, and we have 300, 25. We can graph these on a graph. When graphing, people always ask, well, how do I know which information to put on the x-axis and what information to put on the y-axis? Well, this tells you right here. This is the x-axis, and we were doing time, t for time. This is the y-axis, which is the vertical one, and that was the number of messages, so it tells you what to label it. So I'm going to label mine time, or minutes, on the x-axis on the bottom, and the number of messages on the y. Now we have to figure out how to put the numbers on it. We can't start at 1. On our time, we're going all the way up to 300 minutes, and we do not want to count by ones and go up to 300. So I have to figure out, how am I going to put numbers on this? I can tell by looking at this that they are all multiples of 6, because if I count by 6, 6, 12, 18, 24, 30. So these would all be multiples also of 60. So what if I count by 60s? So at the bottom here, I've numbered it 0, 60, 120, 180, 240, 300, 360. For the number of messages, I look over here at the y values, and I see that they're all multiples of 5. 5, 10, 15, 20, 25. So maybe I could label it by 5. So I'm going to show you that. 0, 5, 10, 15, 20, 25, 30. Now I can graph the order pairs. First, 120, I go to the right on the x-axis, 120. Then I go up 10, and it would be right there. 180, 15. 240, 20, 300, 25. So I can even graph from my function table. A couple more practices. First, we have to write the rule. A team scores 6 points for each touchdown. So we're not doing the extra point field goal, we're just doing the touchdowns. So if you score 6 points for every touchdown, our rule would be that you have to multiply the number of touchdowns times 6. 6 times the number of touchdowns. So x represents the number of touchdowns, and y is going to represent the number of points on the scoreboard. So after one touchdown, that would be 6 times 1, you have 6 points. If you score a second touchdown, 6 times 2 is 12. If you score 5 touchdowns, that would be 6 times 5, which is 30. If you scored 7 touchdowns, that would be 42. Notice that in your x values, also called the domain, you do not have to make them sequential, such as 1, 2, 3, 4, 5. This was 1, 2, 5, 7. They don't have to be sequentially going up. Okay, let's look at one more example. Bob spent 5 more than, remember when translating, more than means to add, 3 times, so we know that this is 3 times what Anna spent. So how are we going to write an equation for that? 5 more than 3 times. So I went ahead and put the 5 more at the end. So I put 3 times and then 5 more. You could also do it 5 more than 3 times. That's the commutative property that we talked about. You're going to get the same answer. So if we plug in, here are the domains that they were given. If she spent $1, she spent $2, $5, $7. If we plug that into the rule, the first one would look like 3 times 1 plus 5. Of course, we do our multiplication first, so that would be 3 plus 5 would be he spent $8. If she spent $2, 3 times 2 is 6, plus 5 is $11. If she spent $5, that's 3 times 5, which is 15, plus 5 is $20. If she spent $7, 3 times 7 is 21, plus 5 is $26. Good luck on making function tables in our lesson today.